Okay, let's try our first example with this rate of change business. And we've got a motorbike and we've got a formula that tells you where it is at any given time in seconds. It'll give you the distance, its displacement, how many meters it's covered. Okay, the bike is approaching a stop sign. Should it stop, the equation will no longer apply. How fast was the bike traveling? How fast? That means what's the rate of change? That means take the derivative of this function. So that's what you do. You go 3 times 1 over 15 is 1 over 5. And you bring it down 1 squared. 2 times 2 is minus 4. Bring it down 1t. 1 times t is 20. There it is. There's your equation. When it's first detected, that's at the beginning. In the beginning, time is 0. You just put 0 in there and you get 20 meters per second. The velocity of the bike first detected 20 meters per second. Let's look at the next question. Show that the bike did stop. Okay, well that means that we need to look at that it stopped. We need to look at when the velocity is 0. So we take this equation and we put it to 0, and then we factor it. Multiply everything by 5, you get that. Hey, that's 10t minus 10 squared. That means at 10 seconds, it comes to a stop. The velocity will be 0. So when it stopped, that means it's not moving. It's when the velocity, the first derivative thing here, equals 0. Let's try the next question. So the bike will stop after 10 seconds, right? That's the story. Okay, let's try the next question. Determine the distance covered while being tracked. Well, all we have to do is we know that it's going to stop after 10 seconds. All we have to do is put 10 seconds into the original formula. 1 over 15, 10 cubed, like that. We get 67,67 meters before it stopped. Because it traveled for those 10 seconds, right? So you just put it into the distancing to figure out the distance. So these 3 questions are really just the trick with them. It's once you figure out what they're asking, it's just picking the right formula and then you're done.